Okay, for 8.4 special right triangles, there are two and only two special right triangles that we need to be responsible for knowing everything about, and most importantly about the relationship between their sides. The first triangle that we're going to talk about is called a 45 90-degree special right triangle. So we're talking about a triangle that looks like this, where one angle is right, because it's a right triangle after all. The other two are exactly 45 degrees. Okay, that's the first one that we're going to talk about.
Why isn't it 90, 45, 45?
It is. It's 90, 45, 45. It doesn't matter how you say it. 45 over 90. That's it. Yes, it would be isosceles. Very good. Okay, we're going to talk about that. The other special right triangle that we're going to talk about today in this lesson is called a 30, 60, 90 special right triangle. So that means I'm going to have one angle that's small, 30 degrees, one right angle after all because it is a right triangle, and the other angle will be 60. Okay? These must be memorized. Okay, we cannot stress enough the relationship between the three sides of each triangle, special triangle, needs to be memorized. Okay, here's the first example of a 45, 45, 90 special right triangle. First of all, the question is, why do you know for sure that this is a 45, 45, 90 special right triangle? Something in the picture gives it away.
X.
What is it? Mr. Lamb, what do you see, my friend?
I see two X's.
Yes, so what does that imply?
It's isosceles.
Very good. So if you see the two legs are the same, that implies the two opposite angles are the same. That's isosceles triangle theorem, right? So now we know that this is 45 degrees, and then this is 45 degrees. Fair enough? Okay, what I want you to do now is we're going to use the Pythagorean theorem. We're going to solve for x. Okay, we're going to solve for x. So we're going to say x squared plus x squared equals 8 squared. How many x squareds do we have on the left-hand side? How many? There's two of them, right? So 2x squared is now equal to, what's a grand total of 8 squared, everybody? 64. So we're going to divide by 2, so that means that x squared has to be what? 32. That means that x needs to be the square root of 32. We need to simplify that, and you should end up with 4 radical 2. So if this is 8, this is 4 radical 2, and this would be 4 radical 2. Okay? So the length of the hypotenuse was 8, the side was 4 radical 2, the other side was the same, 4 radical 2. So what are you noticing right away about a 45, 45, 90 right triangle? What can you always say based off this example right away? Yes? The legs have to be the same. You guys agree with that? The legs have to be the same. So that's one special thing that you should know. In a 45, 45, 90, the legs need to be exactly the same. Okay? Let me give you another example. We'll call this B. Same box here. Okay, I'm going to move this up just a little bit. And for this example, I'm going to give you this picture. Okay, this is going to be 5. This is going to be 5. That's a right triangle. Okay, how do you know right away that this is a special right triangle?
Isosceles triangle.
It's isosceles. Okay, that means that this has to be 45. This has to be 45 because the lengths of the sides are the same. That means the opposite angles need to be the same. And since there's only 90 degrees left, because we have a right triangle to begin with, then it has to be 45. Okay, now I'm going to call this x. This is different than the last example because now you are solving for the hypotenuse. So we're going to solve for the hypotenuse here. And what are we going to get? 5 squared plus 5 squared is equal to x squared. So, okay, so I have 25 plus 25 is equal to x squared. Therefore, 50 must be x squared. So what am I going to do? Take the square root. X is the square root of 50, which is equal to what? Square root of 25, square root of 2. So what do we get? 5 rad 2. So this is a value of 5 rad 2. Okay, so now, taking a look at both of these triangles, what do you notice about them in a 45, 45, 90? What do you notice? Yeah, the legs are the same. Yep, what else do you notice? The angles are the same, yep. What else do you notice? Same shape, yep. Those are rad 2 in both of them, right? Okay, let's get to the theorem. Here's my triangle. We know that this is 45 degrees, and this is 45 degrees. Then this side has to be a leg, this side has to be a leg, and this side has to be a hypotenuse, right? Because the hypotenuse is across from the right angle. Here's what the theorem says. The theorem says this. If each leg is x, then the hypotenuse is x rad 2. That's the relationship that you need to know. Okay? If each leg is x, then the hypotenuse is rad 2 times x.
As long as each leg.
And you'll notice these are the same, right? Those will be the same, right? And that x value is right there. We just tack on the end. We just tack on a rad 2. All right, do you guys see that? All right, here are 2 examples, right? The example A can be done in a flash, okay? Example B takes a little bit more thought, okay? So how are we going to do example A? What do we know? If it's a 45, 45, 90, which in this case it is, exactly, 45, then this has to be 8 radical 2. Bang, we're done. Easy. Those ones can be done in a heartbeat because it's just 8 radical, it's just whatever the leg is times radical 2. Now, the other way goes a little bit harder. Okay, what do we got to do there for this one? If I've got 12x and x, what would we do? Well, now remember the relationship here. Okay, here's the deal. Think of it like this. Think of it like this. You need to set this piece equal to that piece. Do you see it? Because that's where it is. So you would say that 12 must equal x rad 2. Because that's what it says in the theorem, right? The hypotenuse has to be x rad 2. We want to solve for x. What would we do? We would divide by rad 2, divide by rad 2. Therefore, x is now equal to 12 divided by rad 2. But can we leave it like that? No, so we multiply top and bottom by rad 2 over rad 2. And we would get 12 rad 2 over how much, everybody? Over 2. What's 12 rad 2 divided by 2? There you go. Therefore, this is 6 radical 2. So therefore, x is this 6 radical 2, and this one is 6 radical 2. Now, notice how much easier this problem would have been if I gave you the other way, okay? If I gave you this picture and said this was 6 radical 2, and this was 6 radical 2, then you would just go 6 radical 2 times a radical 2, which of course would then just be the 12. So it does still work out, okay? So the relationship says x, x, x radical 2. You got to have that memorized. Okay, here is an example of a 30, 60, 90 degree right triangle. Okay? Yeah, right. What about that second one? Yeah. Here's this first one here. Okay? An example of a 30, 60, 90 right triangle. I like this example because you should see some kind of a relationship here. Because it was oriented the wrong way. I didn't want to do it. Yeah, that's what I just did. Yeah.
Yeah, what if you use pen?
That was such a good triangle.
All right, look at this one. What do you guys notice are the ones that you see right here? Tell me anything that you notice or you see. What are you looking at?
Right triangle.
It's a right triangle. Good. What else do you see? 30, 60, 90. Good. That's a special right triangle. Good. What else do you notice?
The hypotenuse is double one of the legs.
Oh, very good. There's a relationship between these two. The hypotenuse is double one of the legs. I like that. Good. What else do you notice?
The other leg has the first, radical.
Yeah, there's a radical 3 over here. Yep, true.
9 and
9 and 9. Yep, those are also the same. Right? The 9 and 9. Okay, so you guys are all on to what we're about to come up with here, okay? So I'm going to give you the theorem here. And the theorem is going to be written in like the same exact form here. Okay, if this is 30,
Is the theorem still in box five?
yeah, it is. It is. If this is 30, this is 60, this is 90. Okay, so the relationship between the two sides, okay? The shortest side is the key to getting this right, okay? And how do I know which side is the shortest side?
because it's opposite from the smallest angle.
Because it's opposite the smallest angle. So since whatever angle you find the 30-degree angle, you go to the opposite side. That's where you start, okay? You start with x. The next thing you do is you go to the longest side. Which one's the longest side? Opposite the 90 degree, which would be the hypotenuse, right? The longest side is always double the shortest side. Double the shortest side. Okay? The only other side that you have is an x rad 3. And you can remember that from the very first start of the theorem will be in there. Right? 30, 60, 90. So the relationship goes, this is a little story that I always tell myself, okay? In between 60 and 90, in between 60 and 90, you will find x. Okay? 30 times 2 gives you 60, and the other one is x rad 3. All right?
Oh, 3 times 30 is 90.
True. Yeah, you could think about it like that, right? There's a 3 in that one. So the key to getting this right is to find the shortest side. The key to getting it right is to find the shortest side. Find the shortest side, label that x. Go to the hypotenuse, that's double x. The other side has to be x rad 3. Okay? That's the key. Okay, this is the easiest of the examples because you've been given what? You've been given the short side, right? The short side is the easiest one. So find that short side first. It's been given to us. It's 6. Then we go to the hypotenuse. So we double 6 and we get what? 12, right? Then we go to the other side and it must be 6 radical 3. All right? That's where we need to be with this example.
It's not always in the same. It's not always like radical 3's on this side.
No, it's the lengths, okay?
Are you always given one of them?
You're always given one of them. Yep. You're always given one of them. So let's do this one, right? If you can do this one, now I'll draw it a little bit differently for you. Okay, there's 90.
I thought you just said.
That's 30.
So those side opposites.
Okay, I'm going to give you the hypotenuse. Okay, I'm going to give you the hypotenuse is 20. That means this side has to be the 60. Okay? So what do we do now? What do we do now?
Oh, that
Shortest side is 10.
The short side has to be 10. Very good.
Other side is 10 rad 3.
And the other side has to be 10 rad 3. Very good.
How'd you get the shortest side?
It's just
What's the relationship between the hypotenuse and the short side? It's half.
But you never give us any of them.
I did too. I gave you the 20.
I didn't even have time to write this.
This is the hardest one
How though?
because you're starting from the medium side. Okay, this is the hardest one. So if you don't know what to do, you have to resort back to the theorem. And I'll draw it in the same orientation as the picture that we have. Okay? Here's 30, here's 60, here's 90. Here's the relationships that we know. The shortest side is x. The hypotenuse is double x. The other side is x rad 3. So therefore, it must be true that the side that we've been given is equal to x rad 3. So we say 21 must equal x rad 3, and we solve for x. We divide by it. Sorry, we divide by rad 3. We divide by rad 3. So we get 21 rad 3 over 3 when we rationalize. 7 radical 3 is equal to x. Now look what we just did. 7 rad 3 is equal to x. So therefore, this side must be 7 radical 3.
So it's okay.
Now, how do I get to the hypotenuse? We just double the short side. So that would be 14 radical 3.